Alright guys, so this is a 100 horsepower electric motor. This came into our shop to be repaired. This is a Siemens Alice 100 horsepower, 460 volt, 111 amps. This thing was dead shorted when we got it. So then we need to open this thing up and actually figure out what's going on. So once we got that end bell off, you can see that this winding is toast. This bearing is disgusting. I don't know what kind of grease they're using in this thing. There are tons of copper balls inside of here. This failure would have happened pretty instantly and basically would be an arc flash inside this electric motor, shooting molten copper balls everywhere inside. And now I know a bunch of people are going to look at this and say, is that thing even repairable? Yeah, it's totally repairable. And we're going to go through the steps and completely rebuild this electric motor. I'm not really a big fan that they didn't lay this lap. Those coils should have been underneath that other set of coils. We can see here where it's physically been burned. One of the connections that comes in through the pecker head completely burned off. So to get this winding into a state where we can actually remove these wires out because they're extremely rigid, we have to burn this through a burn-off process in an oven. After that, we're going to have to start pulling all of these coils out, and we're going to want to count these coils so that we know how many turns of wire we have. And this is actually wound with 17 wires in hand, so I'm going to have to set up 17 buckets. Sometimes people ask what happens with all that copper. Well, it goes in that bin and it gets scrapped. As I'm pulling out some of these coils, I'm just kind of making notes. We can see that these wires have been fused together because they got extremely heated, they shorted, melted together. And as we keep digging through it, we can see it here, a bunch of broken wires again, and we see them shorted out again down towards the laminations, and another one here you can see right down towards the laminations, fried off. We're going to take a bunch of information as we pull these coils out. We need to know what the pitch of the coils were, how many coils were in each slot, how it was connected. This actually was a 2Y connection. We'll take a bunch of measurements of the core, we'll run all this information, make sure that the winding data that we took is correct. We need to clean all of this blown out copper off of these laminations in here, and then before we do sandblast this, I like to go through this with a flat blade, a flat head, whatever you want to call it, and I'm going to bend all these teeth back before we sandblast it so that we don't get sand in between those laminations. We'll never be able to get them to stack right again. Each step of this process is important to ensure that we're going to come out with a quality product at the end, so we cannot be skipping any of these steps. After it's been sandblasted, we can see all these copper deposits that are on these laminations, and we are going to need to grind these out. And after we get that done, we can move on to the next step of the process. I'm going to spray this with a white insulation paint. This is not just regular spray paint. It does have an electrical rating to it. And after that, I need to insulate all of these slots. So I need to cut 60 individual pieces of paper. I need to crease 60 individual pieces of paper. And I need to put all 60 of those slot liners into the stator so we can begin to put coils into this. If you want to follow the process, make sure you're hitting the follow button. Cheers, guys.